Welcome to Unit 1, Lecture 2. This is over the tissues. I'm just going to give you a little warning here. It's a little longer lecture than our last one, but it's very informative, very full of information, and I hope that it's easy to understand. So our task list for this lecture, first take notes over this lecture here. Then there is a little activity on page 87 of your workbook. It's procedure 1. So I'd like you to complete that and then check it against the key. The key will be posted on Moodle. Then you can complete the homework listed at the end of the lecture. This is all from your workbook. Per usual, it is due on the day of the exam. And then I need you to complete Unit 1, Quiz 2, which is over the information on this lecture. So first we're going to take a look at the general tissue types that we have. What are the 4 major categories of tissue types? Our 4 major ones are right up there, right? We can see them. It's going to be our epithelial tissue, connective tissue, muscle tissue, and nervous tissue. So some functions of these tissue types, they're actually just listed underneath the tissue types up top there. So the functions of epithelial tissue is right there. So epithelial tissue is going to cover the outside of the body. It lines all body cavities. Its main job is to protect you. We have connective tissue, which essentially connects things together. So connective tissue is going to bind, it's going to hold things, it's going to support your body. Then we have muscle tissue. It says on here that it's going to contract. What that means basically is it's going to allow you to move, right? Muscle tissue allows you to move. Contraction of your muscles is what actually causes that movement. And then we have nervous tissue. Nervous tissue's function is to receive and transmit signals throughout the body. So first we're going to take a look at epithelial tissue. The thing about epithelial tissue is that we can have 2 different types. We can either have simple or stratified epithelial tissues. So when we look at A versus B here over to the left, so you can see A and B. When you look at those, one of those is simple and the other one is stratified. Which one do you think is simple? Yeah, A is going to be simple because let's be honest, it looks simple, right? It's not as complicated as B. So when we look at B, we know that that is going to be stratified. Okay, so we have simple and we have stratified epithelium. When you look at the main differences between simple and stratified epithelium, what is it? What is the main difference? Yeah. One versus many layers. We can see that simple epithelial tissue only has one layer. Okay, it only has one layer of cells. Versus stratified, stratified has many layers of cells. So we can see that simple, there's only one. Stratified, there is more than one. Okay, so simple versus stratified. If you're having a hard time remembering that, think of a stratified. So stratified rock has many layers. So stratified epithelium is also going to have many layers. We also have this thing called an apical or apical and a basal surface. So an apical versus a basal surface, there we go. So here's our apical or apical, and here is our basal surface. We can see it there on that simple one. We can also see it here on the stratified epithelium, so here and here. So what is the main difference between these? What is the difference between an apical versus a basal surface? Yeah, our apical surface is our top and our basal is our bottom. Okay, so apical is the top, basal is the bottom. So if you can remember apex, like the apex of a pyramid is the very tip or the very top of it, and basal sounds like bottom. It sounds like the basement, right? So that is definitely something that we can take a look at. We also have different types of shapes for our epithelial cells. So we know that they can be simple or stratified. We also know that they can have different shapes. So what are the shapes that epithelial cells can be? If you look over there to the left, we have squamous or squamous. We have cuboidal, and we have columnar. So those are our different shapes. We can be squamous, we can be cuboidal, or we can be columnar. Looking at squamous, what does squamous mean? Yeah, I like to think of it as like a squash square. Like a squash square is a squamous cell. What about cuboidal? Yeah, cuboidal is a cube. That one works really well, right? So cuboidal is a cube. And what does columnar mean? Yeah, and columnar is a column, right? So we have words that make sense and we can see how they make sense. If you haven't been filling in the meanings of these things, you can go ahead and go to page 63 of your workbook and you can start filling in the meanings of these different types of cells and tissue shapes. So now we're going to get into actual tissue types. This is our first tissue type. When you look at these slides, there's going to be a couple of things that I'm going to point out first so that we have this all down. First of all, I'm going to actually tell you what type of tissue it is. So you can see here I'm outlining this in red at the top. This is simple squamous epithelium that is at the top. I'm going to ask you to label things on page 70 of your workbook. This is something you're going to have to turn in for homework anyway, so you might as well get it done now. I'm also going to have this up here to the top right. I'm going to tell you where we find this type of tissue. Okay, so that's where we're at. On your exam, on your practical, you will have to identify types of tissue based off of the picture. Now, since this is an online course, I'm going to be giving you different pictures. So it's not just going to be like, oh, look at this picture. I'm going to go quick look it up. It's actually going to be something different. So you want to make sure you understand what the tissue type actually is. Okay, so just wanted to show you those things. So looking at this picture here, we want to make sure we're looking at the apical versus our basal surface. We see this apical or apical and our basal surface here. And we can see in between those what type of cells we have. So what type of cells do we have here? Yeah, these are squashed cells. So squashed cells we know are squamous cells. And how many layers are there between our apical and our basal surface? Yeah, we find one. So if we have squash cells and there's one layer, we know that this is simple squamous epithelium, right? Because there's one layer, one simple, and they're squashed, which means squamous. So we're going to find these types of cells in places where things need to happen quickly. This is going to be found in the air sacs of our lungs, which we'll talk about again, when we get to the respiratory system. So we find these in the air sacs of the lungs. All right, our next one that we have here, taking a look at the types of cells, what type of cell do we find in this tissue? Yeah, they look like cubes, right? So they look like cubes. So we know cube should make you think of cuboidal, right? So cube and cuboidal. Looking at again, just your apical versus your basal surface. So again, here's one, here your apical and your basal surface. How many layers of cells are there? Yeah, it's just one. So we have one layer. So in this, make sure you're only looking at one part. So I'll outline this here. This is one layer here. Okay, and then here's another set of one layer. Okay, so hopefully don't let that confuse you. So if we know that we have cube-shaped cells and there's only one layer means simple, cube-shaped, cuboidal. This is simple cuboidal epithelium. Okay. We find these in places where there are secretory activities. Secretory just means that we're secreting stuff. Okay, so secreting things. We find cuboidal stuff where things are secreting. Glands are a great example of where we would find a simple cuboidal epithelium. Next, we have another picture here looking at, again, our apical versus our basal surface. What type of cells do we have here? Yeah, they sure look like columns, right? So these are columns. How many layers do we have here? Yeah, just one again, right? So simple because there's only one layer, and they're columns, so this is simple columnar epithelium. So you can see, hopefully that makes sense there. Looking at that apical surface, we actually have something sitting on top of it. What is sitting on top of our apical surface? Yeah, this stuff called cilia. If you look at the picture to the bottom right, you can see cilia in action. What are cilia doing? Yeah, they're actually considered, they're beating, so they're kind of flopping around. That's essentially what they're doing. And they're flopping around so that we can move items along. Okay, so cilia are there. They're flopping around. They're moving things along. A lot of times people like to refer to cilia as conveyor belts because cilia and conveyor belts are moving things along. We often find simple columnar epithelium in the GI tract, which makes sense, right? So think about GI tract. We need to move things along our GI tract. We can't just let it sit. Okay, so we find those along our GI tract. Next one that we have here, I'm going to tell you that it's called pseudostratified columnar epithelium. So pseudo means fake. So pseudo means fake in Latin. So pseudo means fake. We can remember that. So looking at this here, what type of cells do we have? I don't blame you if this one's a bit confusing and you're just like, April, just tell me what it is. So the type of cells we have here are columns. We can see that they are long columns. Now keep this in mind, it's called pseudostratified. Pseudo means fake, right? So pseudostratified. How many layers are we going to find in a pseudostratified columnar epithelium? One, right? We're only going to find one because it says fake stratified, which means it's faking us out. It's not actually stratified. We just have one layer. So pseudostratified, we have one. It appears that there are more, but there's just one. Notice that we also have cilia here. What are the cilia going to be used for? Yep, the same thing they were used for in our other tissue type. So they're going to beat to move things along. In this case, we find these throughout the respiratory system. So really the cilia are typically found in your trachea, which is like your windpipe. And essentially what they do is they beat upwards to move, or like remove like phlegm and things like that. So you'll feel it in the back of your throat, you'll feel phlegm. That's because of the cilia that have been getting all the garbage out of your trachea and out of your lungs. So you can thank your cilia on your pseudostratified columnar epithelium for giving you that nice phlegm. Here is a better picture of the pseudostratified columnar epithelium. You can see that these things are only one cell deep. They're just trying to trick us. You can see they kind of have like little stalks at the end. Right now, this isn't a type of tissue. This is actually a type of cell that we find in tissues. So when we look at what this is, we're looking at goblet cells. Notice this word here, secretory vessels containing this stuff called mucin. Okay, so what type of epithelial tissue would we find goblet cells in? We find it in columnar and we find it in cuboidal. So when we look back at our cuboidal areas, it was all about secretory stuff, right? Secreting things. And our last slide, the columnar, also had goblet cells within it. I actually had circled goblet cells. So looking at a goblet cell, they have this stuff called mucin in them. What do you think goblet cells secrete? Yeah, they're going to secrete Mucus. All right, so goblet cells are all about secreting mucus. We find these in areas where secretion is important. All right, mucus is very protective. It's going to help us move things along. It's going to help us secrete things out. So mucus is a big deal. The way to kind of help you remember this, I think of a goblet cells, and I think a goblet cell secretes gobs of mucus. So just imagine gobs of mucus, and hopefully that'll help you remember goblet cells. All right, so we are going to continue on. We still have some epithelium to get through. The first one we're going to take a look at here is keratinized stratified squamous epithelium. If you want to be all fancy, you can call it keratinized, but I call it keratinized. Looking here, what type of cells would we have here? Yeah, these are squashed, these are squamous cells, right? So it's written all over the slide here, but these are squashed down squamous cells. Looking here at your apical versus your basal surface, how many layers of cells are there? More than one. Lots more than one. We can actually see a lot of different layers in this case. Again, looking at the picture here, we can see a protein that we can find in this type of epithelium. So what is the one protein? It's not one, there's many, but what is one protein we find in this type of epithelium? Yeah, we find keratin. Okay, so we find keratin in this kind of epithelium. That's why we call it keratinized stratified squamous epithelium. Keratin is a very strong protein. It's going to help protect, which is really important because we find this type of epithelium in the top layer of our skin. So you're going to see that in our next lecture. We're going to talk about the integuments. We're going to see this type of epithelium again. Then we have non-keratinized stratified squamous epithelium. Okay, so these are the longest named ones. I apologize for how long they are. So looking here, what types of cells do we have here? Yeah, we have squashed down. We can actually see it tells you right here that these are squamous cells. So these are squashed down squamous cells. How many layers do we find in between that apical and that basal surface? More than one, right? Many. We can see that there's definitely more than one. Now, there is a huge deal. It makes a big deal about it in their name that they're non-keratinized stratified squamous epithelium. So what protein is not present in this tissue? Yeah, keratin is not present in this tissue. Okay, so we do not see keratin. We find this in mucous membranes. So you can think of a mucous membrane as like an opening to the outside. So like your mouth or like anus area, vagina area, all those are mucous membranes. I always joke about the non-keratinized stratified squamous epithelium because you don't want keratin, especially like in the vagina, because that would just be very uncomfortable for all parties. If you had a very strong and rough protein, that wouldn't work too well. Then we have this tissue here. When we look at the basal versus the apical surface, hopefully we can see what kind of cells they are. So what type of cells do we have here? Yeah, these are cubes. So these are cube shaped, so this is a cuboidal type of epithelium. And how many layers do we have in between that apical and the basal surface? Yep, more than one. Okay, so we know that these would be stratified cuboidal epithelium because we have more than one layer and they are cube shaped. Looking at, it's called cuboidal, right? Cuboidal. So would these cells function more in absorption or secretion? Yeah, definitely secretion because we know that cubes, the cuboidal, are going to secrete. Okay. These are fairly rare in our human bodies, but we can find these in a few secretory glands. So again, things that are going to secrete. Then we have transitional epithelium. So you've gotten used to me saying simple, stratified, squamous, cuboidal, columnar, all those things. And then they throw this at you, which is transitional epithelium. This is our oddball, but it makes sense, which is really, really nice. So looking at transitional epithelial cells, what they're actually going to do is this. You see that little kiddo? He's massaging the little squishy dog. Transitional cells are going to bounce back. We're going to be able to squish them down and they're going to bounce back. Okay? We find transitional epithelium in the bladder. Why would we find tissue that can be squished down and bounce back in the bladder? Because urine is going to push on the wall of the bladder. So urine pushes on the wall of the bladder. We need those cells to be able to squish back. And then when we empty our bladder, we want them to come back. Okay, so they're going to be able to squish because the urine pushes on the wall of the bladder, and then it's going to release, which they're going to bounce back. So transitional epithelium, urinary bladder, because we need that bounce back. All right, we're going to practice a little bit with these epithelial tissues. What I'd like for you to do is go ahead and pause this, fill this out on your own, and then come back and check it with me. So I'll give you about 5 seconds to go ahead and pause this, and then do it, and then check it. All right, so let's go ahead and take a look at these tissue types here. The first row that we have, we know that it's found in the skin. The type of epithelium we find in the skin is going to be our stratified squamous, specifically the keratinized stratified squamous. The shape of the cells is going to be a squash square. Our number of layers, since it's stratified, is going to be more than 1. The next one we find in the urinary bladder. The one we find in the urinary bladder is going to be our transitional epithelium. Then we have simple columnar. We know that the shape of simple columnar cells is a column. Since it's simple, we have 1 layer, and we find simple columnar cells in our digestive tract, right? So we can hopefully remember these, kind of get them down a little bit. Next one, stratified cuboidal. The shape of a stratified cuboidal cell is a cube. We know that it's stratified, it's more than 1, and we know it's rare, so we'd find it in some glands, not too many. The next one we find, its shape is a cube, and it is 1 layer. Therefore, 1 tells us that it's simple.
Cuba is a UN-recognized island country in the Caribbean, Americas, and Latin America. Did that answer your question?
Sorry, my Alexa talked to me, so I'm going to ignore her until she stops. Okay, anyways, so we have a cube and we have 1 layer. That is going to be simple cuboidal. Its location is going to be lining the glands. Okay, so we have glands, cuboidal. Then we have simple squamous. Simple squamous, its shape is going to be a square. Its location for simple squamous, if you remember, that was like the very first one we talked about, that is going to be the air sacs of the lungs. Then we have a column that is 1, but it appears to be more than 1 layer. So we know that that is pseudostratified columnar epithelium. We know that we find pseudostratified columnar epithelium throughout our respiratory tract. All right, we have finished epithelial tissue. Now we are going to hop on over to connective tissue. So this first one that we are looking at is called areolar connective tissue. We find areolar connective tissue in the walls of hollow organs. Okay, so this is a type of loose connective tissue. Looking at this tissue and comparing it to epithelial tissues, how is this different from epithelial tissue? Well, it's not a layered type of tissue with a specific type of cell, right? There's a lot more going on with this type of tissue. Does areolar connective tissue appear to have air spaces in it? Yeah, right? You look at it, you can see like these little white pockets. It looks like there's some air in it. So we know that this kind of tissue is areolar connective tissue. We find these again in the walls of hollow organs. The way that I remember this, a hollow organ would have air in it. Okay, so that's how I remember areolar tissue. Hollow organs would have air in them. Next one that we have is reticular connective tissue. So looking at this thing here, what types of fibers and cells are present in this tissue? Well, it's reticular connective tissue, so we have reticular fibers and reticular cells. We find reticular connective tissue in the spleen and other various lymph tissues. So spleen and lymph tissues. I always look at reticular connective tissue, and to me it looks like burnt popcorn. I don't know if that would help you know where this thing is, but that's what it looks like to me. All right, the next one that we have here, it has these things called adipocytes in them. So adipocytes are a specific type of cell. Looking at that, what does an adipocyte mean? What are we talking about here? Well, if you look at the little words that I circled there, adipocyte is a fat cell. Okay, so it is a fat cell, like a lipid cell. Lipid means fat, so fat cell. So looking at this type of tissue, we know that this is adipose tissue. Adipose tissue is fat tissue. Okay, so both of these pictures are showing us adipose tissue. We find adipose tissue under the skin and it surrounds organs. Okay, so we find it under the skin and it surrounds organs. It's basically there to protect and to cushion us. It's also there to keep us nice and warm. You can see this picture here down to the bottom right. It's a little pillow. Adipose tissue is basically a little pillow for us. It's going to help protect us. It's going to help keep us warm. I also think that this picture is kind of funny because the bird that's on here, this white is actually its tail, but it kind of looks like it's pooping. But that's because I'm friends with lots of people who have children and they're little boys and they think everything is funny that's related to poop. All right, loose connective tissue types practice. You can fill in the types of tissues using the document titled Tissue Types to Fill In. You find that on Moodle. It's just another way to help you study. So we have connective tissues, we have loose connective tissue types. These three pictures are supposed to help you remember what those three types are. So that picture all the way to the left, that is a pipe organ. What kind of loose connective tissue relates to organs? Very good, the areolar tissue, right? The areolar, you think of your hollow organs, that's where we find our areolar. Then we have the picture of a spleen. Spleen along with some other lymphatic tissues. What type of tissue do we find in the spleen? Good, that reticular, right, that burnt popcorn one. And then lastly, we're looking at all that yellow stuff on the belly there. What type of tissue would we find there? Yep, good. That adipose tissue, that fat tissue. All right, now we're headed over to some dense connective tissues here. So these two pictures, both of them, are showing dense regular connective tissue. So both of them are dense regular connective tissue. We find these in tendons and ligaments, so where bone meets muscle, and where muscle meets other muscle. So that's what we're looking at there. Looking at the difference between dense and loose connective tissue, what's the main difference between the two? Yeah, dense is a lot more dense. So dense connective tissue is extremely dense. Everything is more packed together. In loose connective tissue, things are more separate. They're a little further apart. They're a little more fluid. So dense are packed together. So thinking about this and thinking about where we find it, is this tissue going to be weaker or stronger than loose connective tissue? And this is a lot stronger. So dense regular connective tissue is very strong. It's very good at resisting tension. So think about your tendons and your ligaments. I mean, you put those parts of your body to work every single day, and they don't typically rip or break. And that's because it's a very, very strong tissue. What I like to say about dense regular connective tissue, it's like taking like one rubber band. If you take one rubber band and you stretch it too far, it would eventually break. But if you take 100 rubber bands all together and you try to break all of them, it's not going to happen. Okay, dense regular tissue, connective tissue is just like having 100 rubber bands together, and you can pull on those forever and you're not going to break them. We also have, since we have dense regular connective tissue, we have dense irregular connective tissue. So, I mean, we have one, we're going to have the other. So when we look at dense irregular connective tissue, we can see that a couple of differences, but what is the main difference between our dense regular connective tissue and our dense irregular connective tissue? If you just said that dense irregular is irregular, you're just like me. But what I want you to point out is that your dense irregular connective tissue is going to be irregular with twists and turns in it. So it's irregular with twists and turns in it. Looking at this type, this is going to be a very strong tissue as well. So think about taking those rubber bands with that dense regular connective tissue and twisting them in different ways. If you twist and you turn those and you try to pull on it, it's not even going to move, right? It's not going to move. So your dense or regular tissue is going to be twisting and turning and very, very strong. That's why we find this in the skin, and we also find that in the joint and the organ capsules. Because of how strong it is and how much tension it can resist, it's excellent to have on our skin as well as our joint and organ capsules. Right, we also have dense elastic connective tissue. We find dense elastic connective tissue in large blood vessels such as your aorta. Okay, so we find it in blood vessels. Why would it be helpful to have this in large blood vessels? Yeah, because we need some bounce. See little Tigger there? We need some bounce in our tissues. We need them to be able to bounce back after blood gets pumped through them. If you had tissue in your blood vessels that didn't bounce back, you wouldn't be able to push blood everywhere that it needs to go. So our elastic connective tissue, our dense elastic connective tissue, is going to allow some bounce back of our blood vessels so that we can continue to operate the way we should. All right, so we got through loose connective tissue. Now we're doing dense connective tissue here. Again, that document, the tissue types to fill in on Moodle, you can use that to help you complete this here. So we're talking about dense connective tissue here. Looking at these three pictures, hopefully we can kind of see what we're looking for. We have some springs here on the top. We have some twisted up nails here on the bottom, and we have something that can really resist tension. So looking at this first one, we have dense regular. Dense regular would be that little guy who's pulling on that rope because it can withstand a ton of stress, and it's that straight. Everything is very regular with that type of tissue. Then we have dense irregular, which would be just like those nails that are kind of crossed over together, right? Extremely strong, kind of mixed up and mixed together. And then we have those springs, which would be that elastic, dense elastic connective tissue that's allowing for some bounce back. All right, I promise we're almost done. We're on slide 25 of 34. We're getting there. So first we're going to take a look at this stuff called hyaline cartilage. So hyaline cartilage is found in the tissues at the joints, so where bone meets bone, so at the joints. What does chondro mean? We learned that in the first lecture. Yeah, chondro means cartilage. So what is hyaline cartilage made out of? cartilage, okay? It's going to make a really nice surface. If you look at that little picture below here, that little black ball, what kind of surface is hyaline cartilage going to provide for us? Yeah, very smooth, which we want, right? If we have bone meeting bone, we want a very smooth surface because we want those bones to be able to, work together and not crunch. If they crunch together, that would be very bad, very painful. These surfaces allow bones to kind of glide next to each other. Does cartilage contain a vast blood supply? Well, hopefully that picture over there to the bottom left tells you that no, it doesn't. Because of this, cartilage has a hard time healing. So for instance, if you've ever had an ear piercing in your cartilage, it takes forever to heal because it doesn't contain a blood supply. So it's going to take a long time for it to heal. Now, a way to remember hyaline cartilage, we find these at the joints. If you think about joints, joints and getting you high might help you. So joints help get you high. Therefore, hyaline cartilage would be at the joint. We also have fibrocartilage. Fibrocartilage is a tissue that helps bones fit better together. Fibrocartilage is a tough cartilage, but it helps to cushion you a lot. So we find fibrocartilage at the ligaments and at articular discs, which are in the vertebra. So your fibrocartilage is there to help cushion you. It's tough, but again, helping you cushion. Sorry, I don't have anything super exciting to say about this one. All right, we have another type of cartilage here that we're taking a look at. This type of cartilage we find in the ear and the epiglottis, so that's where we find this kind. Looking at the picture here to the left, what kind of fibers do we find in this tissue? We find elastic fibers. Therefore, we know what kind of tissue this is going to be. This is going to be elastic cartilage, right? It's got that elastic stuff. So how is this different from elastic connective tissue? Yeah, elastic connective tissue had those really small coils in it. It was very, very dense and very, very strong. This stuff here is more bendable. It's less strong. So if you look here at this little video of me, there I am, you can see what this is allowing for. So it's allowing us to bounce back. So, right, so when we look here, you can see that we're bouncing back. Our ear is able to bounce back after we bend it. So I remember that elastic cartilage is in the ear and the epiglottis because E with E and E, right? So elastic ear and epiglottis. Our ear is able to bounce back after we bend it. Our epiglottis is actually found in our throat region, and it's also going to snap shut and open. So we need it to be able to bounce back. All right, so we're going to take a little bit of time here to review the types of cartilage. The first question is, does cartilage have a good blood supply? So does cartilage have a good blood supply? No, it doesn't, which is why it takes it such a long time to heal. So what I would like for you to do is to go ahead and pause this video, fill in the answers to this little, what's it called, table, there we go, and then come back to the video and play it so that we can answer all these for you. All right, we're going to take a look here. So we find some cartilage in the ears and the epiglottis. What type of cartilage do we find in the ears and the epiglottis? Yep, good. We find that elastic, right? E with E with E, right? So what does elastic cartilage allow for? Yeah, it allows for some recoil, some bounce back, right? So it allows us to have some bounce back. What type of cartilage acts as a cushion to help bones fit better together? Good, that's fibrocartilage. Where do we find fibrocartilage? Yeah, we find it in our vertebral discs. We also find it in some ligaments as well. Then we have hyaline cartilage. Where do we find hyaline cartilage? Yep, we find it in the joints, right? Where bone meets bone. So hyaline cartilage we find in the joints because joints and high, all that jazz. And what does hyaline cartilage do? Good, it provides a smooth surface so our bones can glide rather than crunch together. We're going to take just a very quick look at bone and blood tissue here. We obviously find these tissues in the bones and stuff running through the blood vessels. I'm thinking about osteo. What does osteo mean? Yeah, osteo means bone. That's what osteo means. If you've ever heard of osteoarthritis, that is bone arthritis. Okay, so we have all sorts of bone. Um, that's what that's what osteo means is bone. One of these is bone tissue and the other is blood. I don't know if you can do this, but can you tell me which one is which? Very good. The top one is bone and the bottom one is blood. So just a quick little overview of what they do. So bone is for support movement. Bone also makes blood, which we will talk about when we get to the next unit. And blood is going to carry things throughout the body in a liquid form. All right, so now we're going to take a look at some muscle tissue. The first kind of tissue is skeletal muscle tissue. Okay, so we find this in muscles that we control. Voluntary muscle is things that we control, right? You can volunteer for something. That means that you're in control of it, right? You decided to do that. So we find this tissue in muscles that we control. So basically anything that you choose to move is going to be skeletal muscle. Okay. Looking at this picture of skeletal muscle, we can see whether or not it is striated or whether or not it's voluntary. So looking here at skeletal muscle, is it striated or not? Is it striped or not? Well, we can see here that it says striations, right there. So yes, this is striated, okay? It does have stripes. And is skeletal muscle voluntary or involuntary? Yes, it is voluntary, which we just talked about. Right up there to the right, it tells you that this is voluntary muscle. The next kind we have is cardiac muscle tissue. We find this tissue in the heart, so cardiac should make you think of your heart. Looking here at this picture, is cardiac muscle striated or not? Okay, again, we can see these right here. They're called striations. This is definitely striated. Thinking about heart tissue, do you voluntarily control when your heart contracts? No, you do not. This is involuntary. Thank goodness that you're not in control of when your heart beats, because then you'd have to be like, oh, heart beat. Okay, beat again. Beat again. That would just be terrible. So that is involuntary muscle. The next one we have is smooth muscle. We find this tissue in the digestive system and in the walls of blood vessels. We can see here. So is smooth muscle striated or not? No, that's why it's called smooth. There's no stripes in it. It is a smooth muscle. Knowing that we find this in the digestive system and the blood vessels, is this voluntary or involuntary? Yeah, this is involuntary. You do not control how fast things move through your digestive system, and you do not control how fast blood moves through your blood vessels. Lastly, we have nervous tissue. We obviously find this throughout the nervous system. So looking here, what kind of tissue is this? This is nervous tissue. And what does this type of tissue do? Thinking back to one of the first slides that we talked about here, this type of tissue is going to send signals throughout the body. Whew, we made it through. Not too bad, about 45 minutes. To help you understand, you can go ahead and go to page 87, which is procedure 1. I want you to go ahead and determine major tissue types of organs. There is a key that is put up on Moodle that you can check your work against. Again, I think it's super important that you try to do it first before you just look at the answers. So please make sure you're doing that. There is homework from this lecture that's due at the time of the exam, again from your workbook. And don't forget to complete your Unit 1 Quiz 2, which is over the material in this lecture.